Welcome to the ML Dropout. Today we're going to talk about how to solve an integer program in Python. So in this video, we're going to be looking at a capital budgeting problem. So suppose we have $14,000 that we want to invest. We have identified 4 investment opportunities, which are investment 1 being $5,000 initial investment, whose maturity value is estimated at $8,000 present value. PV stands for present value. Investment 2, $7,000 initial investment with maturity value estimated at $11,000 present value. Investment 3, $4,000 initial investment whose maturity value is estimated at $6,000 present value. And investment 4, with a $3,000 initial investment whose maturity value is estimated at $4,000 present value. Now, the reason why we're using present value instead of any other type of metric is by using present value, we don't have to worry about the time dimension of these investments, okay? Some of these investments may pay off in 3 years, they may pay off in 5 years. By using present value, what we've done is we've taken whatever the final value is that those investments would have matured to, they've been converted to what that value would be worth today, right? And that's essentially what we're using this problem. If you're familiar with operations research problems or some financial modeling problems, then you're probably familiar with things like net present value, future value. And this is just an easy way to simplify your problem and get everything on the same dimension so that the modeling process is a lot easier to handle. So how should we invest to maximize our present value return on investment? That is the problem, right? So when we're looking at doing an integer program, a linear program, any type of mixed integer and linear program, anything of the sort, first we have to formulate the problem, right? So now we take what is this prompt and we convert it into kind of like a mathematical framework. So we're going to say, given that x1 is investment 1, x2 is investment 2, x3 is investment 3, and x4 is investment 4, such that this formula that I've defined is true. So this formula is how we set up the integer program, or if this were a linear program, for the above problem, right? So what we want to do is we want to maximize your 8x1 plus 11x2 plus 6x3 plus 4x4, which is going to be our return on investment. Now notice I'm not using thousands, I'm using simple integers. The reason why is because when you look at everything, everything is divisible by 1,000. So we should make this easy on ourselves and just divide everything by 1,000. So we divide everything by 1,000, and that is our maximization, objective right there. That's the objective function. And now we say our constraint, or what it is subjected to, is going to be this 5x1 plus 7x2 plus 4x3 plus 3x4. And we have to say that it is less than or equal to 14. So this is our initial investment. So the above is what is our return. The below is what is our initial investment. That is our constraint. We don't have multiple functions for constraints here. We only have a single constraint function. And then we say such that xj, j being any number between 1 and 4, is either 0 or 1. So basically what this says is that xj, or any value of x, is going to be a binary value, where 0 is present when we decide not to make the investment, and 1 is present when we decide to make the investment. So now, how do we set this up in Python? So first we need to import Scipy's optimization package. So we're going to import from Scipy optimize, we're going to import the linear programming package, and then we're going to go ahead and start to define some of what we saw above in the math as variables in Python. So first, our coefficients, the coefficients of our objective function. We're going to go ahead and define all of those. So we are going to define them to be negative 8,000, negative 11,000, negative 6,000, and negative 4,000. Now the reason why we're doing negative instead of positive is because of the way the linear programmer optimizer works in Scipy. Typically, by default, what's going to happen is it's going to minimize your problem. This is okay. Anyone who's taking a course in linear programming or operations research, you should know that you can, to some extent, inversely use a minimization or a maximization problem so long as you formulate your variables correctly. So by using negative values here, we can accommodate the fact that it's going to minimize our problem. And by doing such, it's still going to maximize our objective function, which is essentially what we want. So just keep that in mind. Your coefficients in a maximization problem, they still need to be negative for the linear programmer optimizer in Scipy in Python. So now that we've done that, we need to define the inequality constraints in our matrix. So the initial investments, again, 5,000, 7,000, 4,000, 3,000. Then we have to put that into what is going to be our list of constraints. So again, you could potentially have multiple constraint functions or multiple lines of like constraints. In this problem, we only have one, but Scipy accommodates having 3, 4, 5 different functions, right? As many as you need. And so we have to embed what are our initial investments into another list. So this is going to be a list of lists, just because that's the input that Scipy is going to expect. And then B, which is going to be what we're constrained against. So that 14, what we're looking to be less than or equal to, we're going to put that in a list as well. Because again, you could have multiple values. So it's expecting the values of your different B's to be within a list. Finally, what we do is we define the bounds for each investment decision. So what we're doing here is we're essentially saying each X value can be either 0 or 1, and then by multiplying it by 4, we're going to get this bounds. So let's look at that. So now you can see it basically just expanded that for us. So now we have the bounds of all of our X variables. Now that we've laid out all of this, we're just going to run the linear program. So the way we do that is we want to get the result. We want to store it. So result equals linear program. Pass in your coefficients first, then pass in your constraint functions. Then we're going to pass in, the right side of the constraint function or your B values. We're going to pass in our bounds. Then we define the method. Okay, now here it has highs. It is recommended that you use highs. Highs is kind of a more efficient algorithm than Simplex, but as the title says, we're going to use Simplex. And so I changed it here. We'll hit run. And I did not import it, so I made a mistake there. So we needed to import it first. So I imported it, shift enter, shift enter, shift enter. We have the result. Let's look at the result now. So you're going to see this, kind of messy result. What do we actually care about here? Well, we care about the fact that it did terminate successfully. We do care about what is the fun. That is actually going to be like your function. And then we care about the array. So if we want to just compile that into what we care about this output value here, the success being true. And then this right here, because this is essentially going to tell us what we should be investing in. Okay. So now if we want to look at the result as a maximization problem, we just inverse it. So this would be our result profit if we follow the investment guidance of this integer program. And the investment guidance of this integer program is that we take investment 1 and investment 2. So we would invest the total of 12,000 of the 14,000 that we could have, and our present value return would be 22,000. Well, yeah, so this is how you would do it, guys. If you want to formulate a very basic integer program in Python, you can literally follow these steps. If you want to do something more complex, look out for more content. I'm going to drop a more complex optimization problem on my channel soon. Thank you.